morning, everybody. I would like to present the progress of my PhD thesis about the biotechnological improvements in clinical hemato-oncology. My name is Ádám Szilágyi, my supervisor is Miklós Garami, my SMS is Mark Hennet-3, and our statisticians are Dániel Veres and Gergő Agócs. So my vision is to provide new therapeutic solutions for hemato-oncological patients, but to achieve that, I would like to draw a big picture about our current knowledge about novel therapeutic solutions, CAR T-cells utility on a clinical level. For that, I will have two projects to finish. Firstly, we will compare these CAR T-cell therapy against the conventional therapeutic types. And secondly, we will compare the CAR T-cells with each other. And additionally, we will not just manage the efficacy toxicity differences, we will also look for the cost-effectiveness differences too. So back to the first project, it will be, we plan to finish in May, and this will be a systematic review and meta-analysis. For a brief introduction about the importance of this topic, I would like to highlight that 1/4 of the patients in the oncology, people still cannot respond well to the first few lines of therapy. So these are the patients who need novel approaches. For example, chimeric antigen receptor T-cell therapies could be beneficial for them. This technology already has been used in pediatric and adult patients. So we are planning to identify the oncological patient groups benefiting the most from the CAR T-cell therapy with, of course, the released side effects. Our question is that does the application of CAR T-cell therapies change the rate of toxicity and affect the efficacy compared to conventional cancer treatments? And our hypothesis is that they does. So for that, we examine response and toxicity and survival outcomes. We conducted a systematic search, and then we selected 360 articles, but a lot of them are conference abstract and not accessible data. So it's not that big number right now. So regarding the outcomes, firstly, for the response, we will use odds ratios. For survival, we will use hazard ratios. We firstly checked the overall survival of pivotal CAR T-cell studies compared to the conventional ones. And, but this preliminary result was without subgroups. But later, when we will check the other survival outcomes with a more wider range of studies, we will use subgroups, of course, with a randomization, disease types, and maybe if we have enough data, we can try to do it with product types too. Of course, we will check the response rates too. So this is our first result. The overall survival of pivotal clinical trials of CAR T-cell therapies compared to the standard of care treatment. What does it mean? It means that these are the CAR T-cell studies which led us to the approval of these novel therapeutic agent. And they used in these articles these pivotal trial results to compare them to any kind of standard treatment, which is already used in healthcare. So this is 9 articles, but only one of them is RCT, and there's no subgrouping yet in this result. But what we can see regarding the hazard ratio is that the HR here is 0.37, which is also a significant result. What does it mean? If the hazard ratio is lower than 1, it means that it favors CAR T-cell therapy. So in this result, we can say that it significantly favors the the CAR T-cell therapy. And we can say that the CAR T-cell therapy is, regarding the overall survival, is a 63% better than the conventional care in usage. This is a non-heterogenic result. And I would like to also add that this results message to the healthcare is that we should widen the usage of CAR T-cell therapy in several kind of hemato-oncological patient groups, because these results clearly show that if we use any kind of hemato-oncological diseases, any kind of trials, pivotal trials, the most important trials, this is very clear result that we should give the patients CAR T-cell therapy as much as possible. So, but for the further results, I need to complete the data extraction, and by that I can also give more the already mentioned data about the response, toxicity, and survival. So let's go to the next topic, which is the CAR T-cell products comparison between each other. I hope it will be finished in August, and this is also going to be a meta-analysis. So this is the 5 already approved studies, mostly from the already mentioned pivotal trials in the other project, which could be used in those disease types, but could be seen in red. The importance of the cost effectiveness additionally in this part is that the CAR T-cell therapy is a tremendously expensive therapeutic agent, and since then we need to check which kind of product is the most beneficial for the patient, not just in efficacy, not just in toxicity, but also by the budget. So we ask that does the type of CAR T-cell therapy product affect the efficacy, toxicity, and cost effectiveness? And we say it does affect it. So our clinical implication will be to check that what's the difference in these products regarding the effectiveness, safety, and the budget. So we're going to use additionally some economical outcomes too. We conducted a systematic search in 3 different databases, and we found about 17,000 articles, which will need to be selected in the next few months. So summarizing the thesis, I would like to check the CAR T-cell therapy products, compare them with the conventional therapies, and then compare them with each other, and check the budget impact of them, and we can then now have a full picture that what can be beneficial for us by the CAR T-cell technology. So thank you for your attention, and I would like to close my presentation with a quote from a Dutch neuroscientist, Dick Swab, who said that we must accept the fact that it is possible that we know something without knowing why we know it.
Thank you very much.
I would like to ask, what could be the further application of the CAR T immune cells in the healthcare?
Well, of course, solid tumors are under the microscope right now, but also it's freshly has been showing very great results in rheumatology in the usage against autoimmune diseases. And it was fascinatingly great in these results. But mostly immune cells against immune cells is the best case right now.
Great presentation. I would like to ask about your first plot. What was the sample size? How many patients were included?
Thank you for the question. It's like about per article about between 100 and 200, but so all in all it's like about, I would say 1,500, but the number of patients in the standard of care group is much larger mostly than the CAR T-cell group. So I cannot estimate it better than like about 1,000 and by the CAR T-cell and about 2,000, 3,000 in the standard of care group.
Thank you.
I also have a question. I want to ask if this CAR T-cell therapy is available for pediatric population in Hungary.
Thank you for the question. It's very important that it's in progress to make it available for the Hungarian patients too.
I mean, in your first study, I mean, you actually got 260 papers or something like that, and you said that many of them is not available. And then actually in your other slide that you showed actually that you are going to analyze 113 or so. So what is in between? Because I'm a bit surprised that this is an expensive therapy, as you said. So somebody does the study and then they publish it in an abstract or how? So what is in between? Because that's more than half of the studies. And then how can you handle this? This is not an easy thing. I mean, that applies to everybody, although not at this size.
Thank you for the question. Well, firstly, there's a lot of ongoing studies right now because it's getting to be a hot topic in the hemato-oncology. And also, there's a lot of cost-effectiveness studies which we are working on to use their toxicity data, their survival data. This is mostly a statistical question that what we can achieve with them, but I've selected these articles very conservatively, we can say, and we will see what we can use from them. But there's a lot of conference abstracts which did this number very high. So we will try to find the original articles too for that, and this is why the high number.
How about the elimination of CAR T cells after the tumor has been treated completely? Do you found something from the paper? How we can eliminate the CAR T cells? The tumor has been completely cured. So,
Please, can you say the question again? Sorry.
how we can eliminate the CAR T cells from our body? So the tumor has been completely cured.
Well, so how we get rid of the CAR T cell after the therapy?
Yes, yes.
It gets rid of by itself. Firstly, the cells are getting so the cells are getting tired, we can say, and there's an apoptosis after that if they cannot use it anymore. Firstly, secondly, it gets to be integrated. If we are lucky, it gets integrated into the adoptive immunity. There's a lot of cases when it happened, and it made the patients a long time able to not relapse after the treatment.